rubbed through their bark until the graft was formed. So now we have this above ground graft that's joining these. They may be separate trees, or they may be stump sprouts off the same tree, but they've now grafted together above ground. This is actually quite common in beeches. You'll see it quite a bit in beeches because I guess they're smooth bark. It's easier if like a branch comes over the trunk of another beech to rub through and then graft on. Um, but above ground grafts are not that commonly seen. So a very cool shot. I should mention, however, below ground root grafts are quite common. Most trees growing within about 15 feet of each other are directly root grafted together underground. And oftentimes when I'm out in the woods that's been logged of hemlock, I'll start looking more closely at the stumps because very commonly hemlock trees root graft together, and then after a hemlock is cut, if the neighboring tree was not cut, that root graft supplies energy, and the trunk, the cut stump starts healing over. And what's cool about it is the callus wood that grows over the top of a cut hemlock stump lays down annual growth lines in the bark. And you can actually date when the tree is cut by counting how many of those growth lines there are. So root grafting, very common between trees growing, about within 15 feet of each other. But above ground grafts like this, far less common. You don't see them very often.
This is actually right by our driveway. And it was a red maple, yes. So are there nutrients being exchanged now? And how on earth do you know that it was the tree on the right that had the branch that went out?
Just because it's bigger on, if you look at the base of that branch on the
Uh-huh.
right hand tree, it's bigger diameter than on the left. So it came off the right one. And yes, once those grafts form, energy and nutrients and plant information is flowing back and forth. So I was mentioning this can happen in root grafts between trees, and it can happen between trees of different species. I've even now twice found uprooted hemlocks growing next to uprooted yellow birches that were root grafted together. I've seen that twice now with
Wow.
very clear root grafts between a hemlock and a yellow birch. And of course, once they form, energy, nutrients, even plant information is going back and forth between those two trees. Now, I remember when I was doing my undergraduate work at the University of New Hampshire back in the late 60s, we were taught that trees are simply individuals in the forest and they just compete. That's all they do. There's certainly competition for trees to get up in the canopy where the light is, but we now know that underground they're all connected and energy, nutrients, and everything else is going back and forth. And it's not just competition, there's actually a lot of resiliency in the forest system because of that connectivity and everything sort of supporting everything else. So, luckily, our forests are way more dynamic than we think, and it's pretty cool.
Great. Thank you.
Wow, that is a sassafras. I've never seen a sassafras of that size, and I'm gonna have to believe you it is, but usually that they have a bark that looks quite a bit different than this. So, I mean, that looks more like a maple to me. But where was the picture taken, I might ask?
This was in Pennsylvania, eastern Pennsylvania,
And
uh,
how
near Philadelphia.
okay, and how big in diameter is the tree?
I'd say at least 6 feet,
Oh my goodness. Um,
and it's definitely a sassafras.
Definitely a sassafras. So you had the three different leaf types, the
Oh
mitten leaf.
yeah, yeah.
Okay, wow. I've we do get sassafras coming up in New England, but it's really southern New England, down Connecticut, Rhode Island, places like that. I have seen it as far north as Walpole, New Hampshire, along the Connecticut River in New Hampshire, but generally the biggest I've ever seen them getting to is about 20 inches. I've never seen a sassafras of this size, but certainly an open grown tree. It grew up by itself in the open. It looks like there's a hedge behind it. Certainly the ground is smooth and even. So I don't know if this was just a tree that was in a yard that was
It,
just
it was
left.
it was a tree in a yard, yeah. And in fact, the home changed hands about, I think, 16 years before that, and the previous owner stipulated that this tree not be cut down.
Oh, well, I can understand why.
So,
I don't know how big sassafras get. I didn't realize they could even get this big, but it is really something for a sassafras and quite
well,
spectacular.
what I wondered was, you always see sassafras suckering in the woods, and I'm wondering if there's something genetically going on so that all the suckers kind of came up together. I mean, does that make any sense?
It's possible. I mean, it's hard to say. There is this, I am seeing this fissure that's going down to the ground, sort of in the left center part of that trunk, which means that yes, we could have actual stump sprouts here that fuse together. I'd have to actually look at the tree on site to be sure of that, so that's a possibility. But yeah, quite an impressive specimen. All right, so I can't tell if we have another graft here or not. Two beeches have, yeah, okay, so it's beeches fused together. Yes, so this is another above ground graft. Um, Now, beech can root sprout, so it may be that it's still the same individual, that just different sprouts came up off the root of a beech and then crossed and grafted, but definitely they're grafted. If they're separate trees, they're now fused. If they're the same tree from root sprouts, but they're now fused above ground, again with an above ground graft. And as I mentioned before, this is quite common in beech. You'll see it more frequently in beech than any other tree. So that's definitely what's going on here. And again, it's because those trunks overlapped and rubbed and then fused through their bark. All right, so here we have a stilted rooted tree. I can't tell quite what it is. The tree on the left looks like a white ash. I can't tell what the tree is in the foreground, although if those sprouts are coming off, it looks like a maple. Um, but in any case, when you get above ground roots like this, you get it in one of three ways. You can get it from a tree germinating on the cut stump of another tree. Um, that's one way to get it. And what happens then is the roots sort of either grow out over the top of the stump and then turn down. You can get it when a tree is blown over and its roots rip up out of the ground, and then other trees germinate in that upturned root system. But then the stilted roots sort of like look like a delta radiating out into a mound or a pillow from the earth that was excavated from that tree that fell over. And a third way you get it is on a nurse log, but then the above ground roots are sort of running along the top of the log, and you usually get a line of trees all lined up connected in that way. In this case, I'm pretty much guessing this was on a nurse stump, that this tree germinated on a stump and then, grew down around it. Its roots grew down around it. If this is a maple, if those sprouts coming off this are a maple, that's unusual. Generally, the trees that do this again are our small seeded trees like yellow birch, spruce, hemlock, that germinate on the moss mat and the top of a stump and then grow down over it. And around here, the stumps that are really good at producing, or the trees that are really good at producing nurse stumps or nurse logs are white pine and spruce. They both have wood that rots slowly from the outside in, and after about 25 years have shed their bark and then get a nice mat of moss growing on them. And that's a great germination site again for these small seeded shade tolerant trees like spruce or hemlock or yellow birch. So generally, if you're seeing evidence of nurse stumps or nurse logs, you're probably looking at spruce or pine that were the nurse stump or the nurse log. And I don't know if there's other questions about this shot or not.
Um, I'll just say, we may be having different ecoregions here. Um, I'm wondering, Pam, if this is a sycamore.
It is a sycamore,
Yeah.
and
Okay.
it's along the Delaware River, yeah, in eastern PA,
Yeah, I
central. Yeah.
I guess that makes sense because the leaves, yeah, they could definitely be sycamore. I didn't catch that, but good observation. Um, all right, so this is a tree that had another breakage event. If you're looking up, you will see that the trunk all of a sudden sort of stops and is replaced by small trunks emerging from the top there. So this would have been a breakage event, could have been a live snap tree that snapped off in a wind event. It could have been from snow loading. But it's not just that trunk that broke off. You can see a lot of the lateral branches also broke. So whenever you're seeing a branch, like I'm looking at the sort of the left-hand side of the tree, the branch, the second branch up, you'll see it comes over and then turns up at pretty much a 90-degree angle. And there's a couple on the right that are doing the same thing. These are all breakage events. And my guess is now we're probably looking at snow or ice loading that did it. So the tree has had either one very bad experience or multiple experiences where the trunk was broken off, and then at the same time or other times, branches were broken off. And again, the lowest twig to the breakage becomes the new upward growing branch or trunk. Um, so that's what happened to this tree. All right, here we have another beech, and obviously there's been some clearing around it, and I don't know why, or specifically why, but there's definitely been some soil cleared back and other material removed. So I don't know if there's more that you would like me to address here, Cyan. I mean, in terms of.
Tom, thank you for looking at this. There are two pictures of this tree, which is a beech, and it is in Pennsylvania and it is in my front yard. And this is the profile of the beech tree. The last one showed clearing because I had an arborist come in to look at it. And I was concerned that the newly arrived beech leaf disease was showing up in the tree. He confirmed it was.
Mhm.
And so they, I think that's called an air spade. The arborist recommended excavating the soil off around the tree and then injecting a new, I believe it's a fungicide.
Uh-huh. It's interesting. I mean, I haven't heard of that technique because actually what's causing this disease is actually a nematode. And maybe a fungicide will work on it. You'll be able to tell. I mean, if the tree comes back and seems okay, then the treatment worked. Um, but this is a big problem for us with our beech. I mean, this nematode can expand its range really, really fast. So I think it showed up, just around here in the last couple of years, um, and it moves fast. It can expand its range hundreds of miles a year. So it's a big problem because our beech, we also are already dealing with beech bark scale disease, which is a huge problem. And now having the beech leaf disease on top of it makes it really, really hard for our beeches. To have two pathogens like that working on them is a really heavy load to carry. I'm confident that pretty much all of our trees are going to make it through their bouts with the pathogens they're having. Um, because when you have trees in a continental context, there's a lot of genetic variability in the population. There's always going to be trees that have resistance. So I'm confident that, our hemlocks and our, our ashes and our elms and everything else in the long haul will probably be okay. It may take centuries to a millennia or more. Um, but I have confidence that they're going to be okay. But the beech is the tree that really concerns me because with two pathogens, um, that's going to be a much harder road to sort of travel. I should mention that our eastern hemlock 5,000 years ago was throughout its current range that we see today. And we know that from pollen records. And then from 5 to 4,000 years, there's no evidence of eastern hemlock pollen anywhere. The species disappeared for 1,000 years, but then came back. So most likely what happened was an exotic pathogen came in, really nailed the hemlock, But there were hemlock trees that were resistant. They became the breeding population, and eventually that resistance built up and the hemlock came back. And so I am confident that will happen with all of our regional trees, but the beech I'm concerned about.
So Tom, this one, this tree has beech leaf disease, which we observed in the leaves. It also has the bark disease, and I don't know if it's visible. There are fissures and little pock marks in the bark that sometimes weep. Um, and I think one reason they wanted to excavate was that there was fungus um, growing on the north side, the uphill side,
Hmm.
down around the roots.
Hmm.
The next picture shows the upper part of the tree, which clearly has had breakage in the past, and I wondered if you had any comments. This beech is located very close to the white oak, which was the last slide.
Yeah, so I did see some elbows on the shot after this one on this beach, which again is probably snow or ice loading damage from breakages. So we can see them. So you can see again the top of that beach snapped off, and then the branch, the upper branch on the right has a very clear elbow where there was breakage. So I'm guessing that this tree, like the neighboring oak, probably suffered the exact same ice storm or ice storms.
Oh, I
All
had a
right.
question for the previous slide about beech in the Northeast.
Yeah.
Just a personal opinion I'm asking. I know a lot of foresters in the Northeast they'll try to eradicate beech from their forest stands right now by cut stumping them and herbiciding them.
Mhm.
How do you think that'll affect the rootstock when it comes to like hundreds of years from now after it being eradicated and essentially poisoned?
Yeah, well, I mean, I don't think that's the way to go. Let's say if you have beech bark scale disease in a stand, a better way is to actually cut the trees high, around 4 feet up the trunk. Because if you, let's say if you cut beech at ground level and you don't use herbicides, you're going to get this incredible regrowth of stump sprouts. And I think a better way to do it would be just to cut them up high. They don't stump sprout. And what is good about that is we do have in our stands 3% of our beech trees are resistant to beech bark scale disease. And uh, by not having root sprouts come up, if you cut the trees down low, it allows germination sites for the resistant beech trees nuts. So I think that's a better way to go. I wouldn't have tried to eradicate it. I'd try to manage it in a way that can uh, sort of cut the compromised trees up high and leave areas where then resistant trees have nuts that can seed in. So that's the way I would go.
Is beech scale resistance still kind of based upon how thick the outer bark is, or is there new research that has shown something else?
No, it's very much based on thickness of bark. So that's why, the larger trees, if they're not wounded, do fine. I mean, the bark's too thick for the stylet of the scale insect to get through it. But if a tree gets wounded, then all bets are off because the fungus can then sort of invade on its own. Um, but there are stands. I haven't been down to see it. I'm almost afraid to go down. But down in Rhode Island, there's actually some old growth pockets of beech, which are marvelous to see because these are trees at 5 to foot basal diameters that are forest grown trees with, I mean, the last time I saw them, which was probably 10 years ago, beautiful smooth bark, and it's just dramatic to see. Um, so that's one of my concerns about losing the beech. It's not just losing a very important ecological tree, but one that is aesthetically so different. Uh, because it's our only tree that, as it ages, retains absolutely smooth bark if it's healthy.
Thank you.
All right, so here's two separate shots. On the right, I'm pretty sure we have an aspen, either a big tooth aspen or regular aspen, that basically got attacked by carpenter ants, and then pileated woodpeckers have moved in. And this is not uncommon at all. Aspen is very prone to decay, and ants quickly move in because carpenter ants like decaying wood. It's much easier to dig, excavate galleries in. And so the woodpeckers come in and go after the ants. So this is really, really commonly seen in our aspens. And then on the left, we have two hemlocks growing next to each other that someone placed a rock in between. That did not get there on its own. That was somebody thinking, oh, this will be fun. I'll put the rock between these two trunks. And eventually those trunks will grow around it, and that rock will disappear as those trees age. Pity the person that may cut that tree down, because if they have their chainsaw going through that and they hit that rock, that's going to do a number on their saw. But in any case, yeah, that was definitely somebody placing that rock there. That was not a natural occurrence. So I guess if no other questions on those, we can go on the next one. All right, so here we have a stone fence, and it's running down, and I can't quite tell from the shot, but on a fence like this, I would start looking to see if there were many fist-sized rocks incorporated into it. Any fence like this, if I get a lot of small fist-sized stones in it, I know that it abutted a crop field. Because crop fields are the only sites that both generated small rock from the annual plowing and then necessitated its removal. So if you have a site like a hayfield that's just only been used as a hayfield, then it's plowed a few times initially to get rid of the pillows and cradles or pits and mounds because they get in the way of working a scythe. But after that, it's not plowed anymore, and small rocks don't come out of hayfields. They don't come out of, our lawns or things like that. They only come out of sites where there's no perennial roots to hold rocks in place because the roots in a forest or in a lawn or in a hayfield, they stitch the ground together as a unit and rocks are held in place. So if the ground freezes and expands in the winter and then thaws and settles in the spring, the rocks do not move. They stay where they are. But in a crop field that has no perennial roots, freeze and thaw cycles lift rocks up, and when they get to the surface, they have to be picked out. I can see that the ground on both sides of the wall is smooth and even. So it was plowed. And again, if there are a lot of fist-sized rocks in this wall, then it's probably a good bet it was cropped on one or both sides. So I don't know if Rhoda, can remember when taking the shot if there are a lot of small fist-sized rocks or not, but that would answer the question about whether this was crop field or hayfield. All right. So I guess we'll move on, but it's one of the two. And again, small fist-sized rocks, great evidence of former crop fields.
Yeah, I don't think I see Rhoda in the list, so they might not be here.
Okay.
Also from Rhoda.
All right. Well, this is a granite boulder that got dropped by the glaciers and then split from a crevice that was in it. And then snow getting down in between those rocks through time. Every winter, if the snow load builds up, metamorphoses into ice, and as the snow turns to ice, it expands and then pushes the rocks apart a bit. So this looks like it's been displaced maybe 2 or 3 feet since the time the glacier deposited this boulder. Uh, I think the biggest I've ever seen movement like this is maybe 5 feet. And I think after that point, it's just too far apart for um, the ice to really form that thick to be able to push it out further. But that's what happened here. The boulder was deposited, then there was a crevice that formed, it snapped apart, and then through the years, snow getting down in that area, metamorphosing into ice, has spread the boulders apart a few feet. All right, so here we have either an active or abandoned beaver pond. This was once looks like a coniferous forest, a lot of standing snags in here with a lot of branches on them. And so beavers dam up an area to flood it, and the flooding kills the trees, leaving these standing snags. And eventually, on a site like this, I don't think it was probably active for a long time because pretty much all the trees I'm seeing that were killed were coniferous trees, and that's not a favorite food for beaver. They like hardwood. So unless there was good adjacent hardwood forests, this beaver pond might have been short-lived. If it is still active. But my guess is it's probably not active. Just looking at all the emergent vegetation growing up, my guess is that probably water levels have dropped and it's now going through wetland succession.
Oh, there it
This
is.
one, this one I think came out.
Yeah. So obviously this looks like it's probably an abandoned beaver pond. I can see that the
I took,
well, I'm just going to say it looks like the picture on the left looks like an abandoned beaver pond. I think I'm seeing the dam, but it looks like the water level is dropped down a foot or two from the height of the dam. It looks like there's also herbaceous growth on the dam, and if that's the case, that means yeah, the beavers had abandoned this at the time the photo was taken.
So I think, Tom, I think that these two sets of photos go together, and I think, and Karen said in this first set of photos that back in, let's see, okay, I won't go back now. There we go. Back in 2018, there was all this water here, and then a couple of years later, it's totally gone.
Yeah,
So.
that's because the beavers abandoned the site. In other words, there wasn't enough of a winter food supply for them. They need, hardwood trees of a certain type that they like to eat in the wintertime. And once, they have to travel much more than 200 feet from their pond margin to find those trees, they abandon the pond and move on to start a new area. So this was abandoned. And my guess is that without the dam being maintained, it breached and the pond drained and went through wetland succession.
Yeah, thanks, Tom. It's just an example of, there's beaver, but how long can a beaver really maintain an area? This is like 6 years later,
Um,
and like you said, there's no food anymore.
yeah,
They were eating like the aspens that were around this area, and now, and the aspens all disappeared, and then this other stuff grows up, and I just wondered about the succession in an area of the plants. Is it always the same? What does that depend on?
it can be very different each time the successional process starts based on timing of abandonment, what seed sources are available, things like that. Um, but if you have a good food supply, beaver ponds can be active for quite a long time. I mean, there was one at the north end of Jordan Pond. So we saw an image earlier from Jordan Pond over in on MDI that beavers moved into that area shortly after the 47 fire because it generated a really good stand of aspen. And they were there for probably a good 40 years. As a matter of fact, the largest beaver lodge I ever saw was there. The lodge must have been 30 feet in diameter and maybe as much as 12 feet in height. Matter of fact, the beavers would drag sticks up and they'd give up halfway up and not get them up to the top. But if a habitat is more marginal, it doesn't have as much of a good hardwood food supply, then the beaver pond can be quite short-lived. So it depends on, the food source that's there at the time that they colonize. And I should mention that beavers will often colonize the exact same sites. You can often actually do coring and find that the dams are on sites where there were previous beaver dams many times before, because eventually, as regeneration takes off and you get hardwood trees growing up, it becomes a good site again, and beavers will move back in, often dam up that stream at the exact same site, and the process will repeat. So a lot of the beaver meadows we see like this have been cycled through many times by many generation of beavers over the centuries.
Thanks, that's interesting. Thank you.
All right, so
So Tom, I can explain this a little bit.
maybe
Susan.
you should.
Yeah. Yeah, this is we've a number of years ago discovered this stone wall in the middle of our woods. It's not that far from the road, and there was a farm across the road, and our land was part of that farm.
Uh-huh.
But I took these are sort of a succession of pictures, starting with the left, just going down what is now, we use it as a trail.
Uh-huh.
And one thing that's interesting about it is that it was a stone wall. Unfortunately, you can't see it. I took this picture after our recent snowfall. The
That's
rocks are not, they're fairly large. You don't see small rocks, but it's not a high wall. It's probably at most 2 feet off the ground. So I wonder whether the rocks have sunk or the duff around it has built up. But at the end and along our property line, there's this fencing, which we've always called sheep fencing.
It is sheep fencing.
Yeah.
I saw, but I saw it after you started talking. But yeah, on that right-hand shot, that is definitely sheep fencing. Barbed wire was not used for sheep because in heavy fleece, the sheep can't feel the barbs. They can get entangled in the fencing and actually hurt. So you had usually just smooth wire mesh fencing for sheep. It could be that it's not really a stone fence or a stone wall. It might be a stone dump. Um, if you had land at one time that was being, let's say, cropped or hayed, and there were rocks that needed to be removed, and there wasn't an abutting pasture next to it, they often didn't build a stone wall. Stone walls were built solely for keeping livestock in pastures or out of crop fields or out of hay fields. So if you had a crop field or hay field that wasn't adjacent to a pasture, there wasn't really a need to make a wall. So oftentimes in those cases, the stone was just taken to the edge and dumped. So you often get a wider sort of structure of low-lying stone that's not really built up in stone work. It was just stumps. So that might be what's going on here. I'd have to see, but that would be my guess, just because it looks like it's wide and low.
Right. It's fairly smooth. I mean, you can walk on it very easily, but that may just be the duff building up on it.
Yeah. My guess is then you're looking at a stone dump there was no need to build a wall because again, walls were built strictly for maintaining livestock. So if there weren't livestock present, then you wouldn't need it.
Okay.
All
Thank
right.
you.
And that is our last slide. So if anyone has any other questions, feel free to ask Tom or yeah, put them in the chat box. And I'm just going to quickly look in the chat box. And Val Libby asked, excavate around tree roots, sensible. And I would assume that that's probably a question about that beech tree where they were excavating.
No, I've never heard of that before. I mean, it's not what happens naturally out in our forest. I mean, we do get some critters that will burrow in under the roots of a tree, but it's like in one site. It's not excavating all the way around. So generally, I believe that our trees have learned how to do things the right way. So I'm not sure that measures like that necessarily help. I mean, I don't know for sure, but in any case, that's my feeling about it. I should mention this is a good set of slides. It gave a lot of good material for me to talk about. So sometimes I get stuff that there's not a lot there, and I don't have much to say, but this was actually very productive for only 20 shots, quite productive.
Yeah, and so thanks to everyone who sent in stuff and yeah, made it really interesting. We got another question here in the chat box that said, Karen Zimmerman says, so fine to see images from others explained and answers to things I have wondered for years. Hope we can do this again. And Robin Hadlock says, thank you. So thank you guys. Appreciate it. And thank you, Tom. Yeah, this is great.
My pleasure. I should mention, I got this idea because I think when the pandemic hit, if someone asked me to do a Zoom program, and I talked for an hour just looking at myself the whole time. And I thought, this is not very satisfying at all for me, and I bet it's not very satisfying for people there. So I came with the idea of like people submitting photos, and it could be interactive like this because I think it's a much better way to go than just having someone talk for an hour. So
Yeah, that was great. Well, if there's no further questions, we'll say thank you to Tom and thank you all to being here. And if you have any other questions, feel free to email me, and then I can forward you Tom's information. And
yeah, just be sure to do that. If questions come up, you can email Marin. He'll forward them to me, and I can get back to you then.
awesome. All right. Well, thanks for being here, everybody. I really appreciate it. And I hope that you all have a great rest of your night.
All right, very
Tom.
good. Bye bye, everyone.
Have a good night.
Thank you.
Very welcome.